we kind of breezed over hoisting in the last video. We were talking about execution contexts, and we said that when JavaScript code is executed, there's a creation phase and an execution phase. And in the creation phase, it scans through, like the interpreter scans through and looks for variable declarations, function declarations, and in some occasions, when it needs to, it will hoist them at that stage. So what does that even mean? Let's have a look at some code. So looking at this first function here, I got a little title there, function hoisting, big clue, big clue. So you can see we are calling a function and then we're defining the function afterwards. Now what's wrong with that? You probably already know. Functions should be defined before you call them. How does the interpreter know? How does the engine know what this is? How does it know when it's running the code? Well, let's have a look. Something to mention here as well, we've gone to dark mode. A friend of mine suggested having things a bit darker on screen, because when you switch from the camera or like to slides, and it's a bit like, whoa, especially if you're watching in a dark room. So thank you very much for that suggestion. Yeah, and I like it as well. I don't know why I didn't have dark mode anyway. It's super cool. Anyway, sorry, let's focus. So what's happened is the function works. The function call worked, which is weird because, as we said before, this is a bit crammed, isn't it? Yeah, the function was called before it was defined. So what has happened is the engine has gone through, and when it saw this function declaration on that initial sweep, in this instance it would be in the global creation of the global execution context. It would go through, it would find this function, say, hey, we'll put some memory aside for that, but it also says, okay, let's pull it up to the top. So this will, as the code's executing, will actually be above this function call, and that is very behind the scenes, because as you can see, looking at what we feel is the source code, and we can debug it, you can't really see that. But yeah, this in execution order actually exists above this, and that is hoisting, quite literally like the verb, just getting pulled up to hoist. Cool. So let's look at another example. Comment that out, and we'll uncomment this. Now this one, what's gonna happen here? So we've got console log of A before it was defined. Here's A itself, and then we've got another console log after it was defined. So you can have a guess at what those values will be. A fun game. We've also got function B here. I don't seem to have put a call, so that's not gonna get executed anyway, is it? But it's very much the same as this one, but it's inside a function. So let's call that function as well in the code. Jeez, it's like a live coding exam, hey? Your fingers all go to pieces. Okay, right, so let's save that as well. Let's flip on over. Give me that console. Okay, so this is quite interesting, right? Hopefully. Because I mean, when I started learning JavaScript, I would obviously expect it just not to work, because you're trying to reference something that doesn't exist in the code. We're here. Do you know what? I was trying to make the text a bit bigger to be helpful, but let's make it a bit smaller there. Yeah, because at this point A doesn't exist. Look at the logs again. See, the first A is undefined, and the second console log of A has the value. Same with B inside this function here. After it's called, it's undefined, and then it has the value that it was assigned. So how's this happening? Well, stupid question. This is a video tutorial about hoisting. So yeah, it's obviously hoisting. What is happening, though, is a bit different than the one that we just looked at, isn't it? So what actually happens is this declaration of the variable is moved to the top. So it would just be var a. And then if you think about that, that is what's happening, right? In the creation phase, in this point, it would be the global execution context. So when that's created, it says, oh, okay, we've got a variable. I'm going to set some memory aside for that. And then it's hoisting it, it's pulling it to the top of the code. But that isn't the, it's not got its value. It's undefined. We've just moved it up to the top, but it hasn't got this assignment here. So this assignment of the string, did I get hoisted or, that actually stays where it is. So if you can imagine var a just being moved up to here, so it's declared, and then this is logging, and it says, okay, r's got no value, it's undefined, that comes out, then this line stays as a equals this string. Cool. And then it's logged, and that's how we get those two there. And now f, this is just to show this is exactly the same here, because this is the global execution context, this is a function execution context, and as you can see, it works exactly the same but within the function. So this var b is getting pulled up to the top of the function inside here. So it'd be var b console log b, and then b equals how about me. Cool. Moving on then, we will comment out this one about the variable var hoisting, and we will uncomment this one, and we will save it. So this one is very similar to the last example, the difference being that we are going to use a const and a let instead of var. So can you have a guess what is going to happen this time? Yes, lots of fun games today, huh? So yeah, have a guess, and we'll look at the results. Whoa! Cannot access C before initialization. So what has happened here? So let and const, they are hoisted. They're still hoisted. So let's have a look here. So we got the error here. This kind of conceptually is still being pulled up to the top of the code. The difference is, I said like var wasn't initialized, that var was empty, so like var a would be pulled up to the top. That's not entirely true. So var is declared, pulled up to the top of the code, and it is sort of initialized. It's got the default initialization, which is undefined, saying okay, we've got nothing. Whereas things like const and let, they get pulled up to the top of the code, but they don't even get the default initialization. So they have no, not only do they not have like this value, they don't even have undefined. They're just not ready to be used. That is called the temporal dead zone. That sounds pretty serious, doesn't it? But that's all it's really referring to. Yeah. So that's the mystery solved, really. You just can't use them. You can't use the variables until they've actually been assigned a value, which is good, really, because it makes the code behave as you would expect. Cool. Yep. So we failed on this one. We can have a quick look. Just to, oh, jeez. Really butterfingers today, huh? I commented out the wrong one. I mean, I could just re-record this, but let's all go along for the ride, huh? Yeah, there you go. You can see same error, same deal. Moving on then, we'll comment this out, and we will have a look at function expressions. So function expressions, with functions being first class functions in JavaScript, you can store them in a variable, which is great. But do they get hoisted? Guess away. So we are logging floaty brackets. We are logging out the function expression before it is defined. We are then gonna call it, and down here it is defined. So maybe I should put another one in here just to, just in case it works. Ready? Let's have a look. Ooh, so what's happened? So we're getting an undefined from line 37, and line 38 is giving us a func_exp is not a function. Wow, what do you think? So it's the same theory as before, right? So func_exp variable is going to get created. It's going to get pulled to the top. So it's just not been initialized yet, aside from that default undefined value, because it's a var. So this is undefined. Great. And then you're calling function expression. You're calling it, say, hey, please execute the function expression. And JavaScript Engine is saying, well, there isn't one. There isn't one. Like all I've got in there is undefined. So yeah, that makes a lot of sense, I think. Moving on again, we will comment out function expression hoisting, and look at the last one, class hoisting. Again, I think I could do with a few more console logs in here. And again, I've completely lost the ability to type. Okay, last game, folks, last fun game. What's gonna happen here? I reckon you can probably guess. So we're gonna log hoisty. We're gonna try and create a new instance of the hoist class, and then we're gonna try and log it. Now what happens? All right, yeah, very similar to before, right? So the variable is getting hoisted. Great. It's a var, it's undefined, and then when we're getting down to here, so class is actually hoisted as well. This class definition, it is pulled to the top, but it hasn't been initialized. So it's got some kind of reference. It knows a hoist class exists, but similar to the way this var is not been initialized, neither is this. So you can't use it. If this was a class expression, so you would have this in a variable, var blah 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 equals class hoist, it's the same deal again. And I mean, this is the final example, and it brings us to the main point, I suppose, because it's good to know about hoisting. But basically, why are you writing this weird code? You wanna define things at the top of your code. If you really, you need to define the value later on. Okay, that's fine. But at the very least, you want to have your declarations at the top of your code, the top of your function, and then you want to give them a value as soon as possible, really. And yeah, just don't write weird codes. Do you know what I mean? If you've got a class, what's it doing down here? So that is the end of this video, and apparently my main takeaway is don't write weird code. Great, huh? But hopefully you enjoyed the video, even if the main takeaway is a little bit rubbish. And hopefully you will join me next time for some more rubbish. Thank you very much. Bye bye.